Section 6.3, medians of a triangle. So we have some vocab words here. The first one is the median of a triangle. And the median of a triangle goes from a vertex to a midpoint. So if you have a triangle like this, the vertex is a corner. So there are 3 vertices. And you know a point is the midpoint because of the congruency marks on each side of that point. And the median is the line that connects the vertex to the midpoint. Now, if you were to take your triangle and you were to draw all 3 medians, so there's a midpoint, connects to the vertex. Here is a midpoint. It connects to the opposite vertex. And here is a midpoint, and it connects to the opposite vertex. If drawn or constructed correctly, these 3 medians should have a point of concurrency. They should be concurrent, and that point is called the centroid. The centroid kind of sounds like center, and in fact it is. It's the center of the balance. So if we were to cut this triangle out, this spot right here, the centroid, would be where the triangle would balance. Let's say you balanced it on the end of a pen or a pencil. That's the point that you would use to get a perfect balance. So the next one is the centroid theorem. And the centroid theorem is, if you have the centroid, like this, the distance from the centroid to a vertex and the centroid to the midpoint, the distance to the vertex is twice the distance to the midpoint. So if this distance was 3, this distance is twice that, it would be 6. And that's true for all 3 medians and the centroid. So let's do example 1. Point D is the centroid of the triangle. Find CD and CE if DE is 7. So the first thing I would do, I would put the 7 in the picture if it's fairly simple to fill in. So DE is 7. That goes here. And we know that D is a centroid because it says point D is the centroid. So that means the point from the centroid to the midpoint and the distance from the centroid to the vertex, the center to the vertex is twice the center to the midpoint. So if this one is 7, 7 times 2 is 14. So DC is 14. Now they also ask for CE, which is this entire length from C all the way to E. So we're going to use segment addition. If this one is 14 and this one is 17, add them. 14 plus 7 equals 21, which means CE equals 21. Example 2, point P is the centroid of the triangle. Find PN and QP if QN equals 33. So here, the problem with putting this 33 in the picture is that the 33 is this entire length from Q to N. It's kind of difficult to put that in the picture without making things really complicated. So I'm not going to write that down. And the problem, what makes example 2 harder than example 1 is that in example 1 they told us the short piece and they wanted the longer piece and then the whole piece. Here they tell us the whole piece. We kind of have to work backwards. So what I'm going to do is I'm going to put an X on QP. That's some number that we don't know. Well, that's the shorter piece. The longer piece is twice that. So if this is X, this one is twice X, known as 2X. And then we know the whole length, when you add them, X plus 2X is the 33. So 3X equals 33. Divide both sides by 3, and X equals 11. So QP is 11. PN is twice that. So 2 times 11 is 22. So PN equals 22. These are the two standard examples of medians. We're not going to do the constructions. What we are going to do is we're going to switch to the second page of 6.3, and we're going to talk about these vocab words. So the second half of 6.3 is about an altitude. And you guys have heard altitude before, probably. I hear it the most. When I hear the word altitude, I think of two things. I think of an airplane flying at an altitude of however high. And I also think of altitude like if you're driving up through the mountains, there could be cities with like an altitude or an elevation that is the height listed in the city. Altitude is the height measured straight down at 90 degrees. And this is the altitude of a triangle. It goes straight down at 90 degrees. It may or may not go through a midpoint, but it does go through the vertex. The tricky thing with altitude is that if your triangle is kind of like tilted to the side, the altitude is the line that it may not even be in the triangle, but it is at 90 degrees and it does go through a vertex. The orthocenter is the point where if you were to draw the three altitudes, the orthocenter is where they cross. It may or may not be inside the triangle, but those three altitudes will cross. They are concentric, they will cross. Sorry, they are concurrent, they will cross. So things to watch out for the altitude. They go through the vertices and they have 90-degree marks. They are perpendicular. So just to put it, there's a nice little chart here in the notes of all 4 points, the circumcenter, the incenter, the centroid, and the orthocenter, and what each could look like. So for the circumcenter, those are perpendicular bisectors. They're 90 degrees, and you'd have midpoint noted on your paper. Angle bisector, you're going to have the angle marked. Median, you have midpoint marked, but no perpendicular. Instead, it goes through the corner, the vertex. And altitude is perpendicular through the vertex, but it does not have the midpoint marked. And then, of course, each picture, each point of concurrency has a special rule. So the circumcenter is equidistant to the vertices. So this line, this one, and this one, those three line segments have equal length. In an angle bisector, the distances to the sides are equal. In a median, nothing exactly is equal, but it's twice. So if this one is 4, this one is 8. If this one is 5, this one is 10, and so on. And for the orthocenter, there are no special properties that we are doing for this class. Now, we're not going to construct any of those. What I want to do is look at the review for 6-1 to 6-3. This one is more of what you would see on a test or a quiz. Say the final exam could have something like this. So the first one, number 1, state the point of concurrency for each of the following constructions. So the angle bisectors create the incenter. We are naming the point. The perpendicular bisectors make the circumcenter. The medians make the centroid, and the altitudes make the orthocenter. They may not always be in the same order. If you look here, we did the circumcenter first, but here the incenter is listed first. Number 5, the circumcenter of a triangle is equidistant to the vertices of the triangle, and the incenter of a triangle is equidistant to the sides. And the centroid is blank the distance to the vertex as it is to the midpoint. It is twice the distance to the vertex as it is to the midpoint. So that's just practicing the vocab and knowing the rules. Example 8 is a really good example. And it looks super difficult to me. Like there's a lot of information here. There are 9 questions and there are a bunch of numbers up here. But they go pretty fast once you get the hang of how these work. So D, E, and F are midpoints. AE equals 5, CA equals 12, GF equals 3, FB equals 8, and AG equals 7. Mark the rest of the triangle with the appropriate information. So G is the blank. We're looking for the name of the point. Let's see here. We have 90-degree angle marks, and we know that D, E, and F are midpoints. So D, E, and F are midpoints. That means that this piece and this piece are congruent. EB and EA are congruent, and DA and DC are congruent. So once we mark those in the picture, we have a perpendicular bisector, which means G is the circumcenter. All right, next one, EB. EB is here. Well, let's write down what we do know. We know that AE is 5, so let's put that in the picture. We know CA is 12. GF equals 3. FB equals 8. And AG equals 7. Now AG is not actually in the picture, so I'm going to draw that one in. And that is equal to 7. All right, now let's see. EB. EB is right here. 2 tick marks. 2 tick marks, so EB is 5. AB now, the whole length, if this is 5 and 5, the whole length, 5 plus 5, is 10. CD is next. That's this piece right here. Now we don't know, this one has 3 and this one has 3. They need to be the same. Together, they equal 12. So 12 divided by 2 is 6. CD is 6 and DA is 6. So AD is 6. CF. CF has 1 tick mark, FB has 1 tick mark, so they're both 8. BF is 8, it's already marked. CG, this length, and BG, this length, are the only 2 questions left. And the trick is, with a circumcenter, the distance from the circumcenter to a vertex is always the same. So from G to A is the same as G to C, which is the same as G to B. These are both 7. The next one, angle EAG equals 35 degrees, angle ACF equals 50, GE equals 4, GK equals 5. Mark the rest of the triangle with the appropriate information. Let's see here. EAG is 35. That goes here. ACF is 50. That's this whole angle here is 50. GE is 4. And GK is 5. They only give us 4 numbers this time. G is that. We're looking for the vocabulary word to describe point G. Now we do have perpendicular symbols. But notice what else we have. We have angle congruencies in each of the angles. So these lines here, these rays actually, are angle bisectors, which means G is the end center. And now we can fill some things in. Angle GAD. GAD. 2 swish marks, congruent to 2 swish marks, it's 35 degrees. Angle EAD. EAD is the whole top angle. E to A to D. So if this piece is 35 and this piece is 35, add those together using angle addition postulate, and we get 70 degrees. Angle ACG. ACG. That's this little swish right here. Just this little piece right here. Now, we don't necessarily know that one, but we do know that these two are the same, and together they add up to 50. So 50 divided by 2 is 25. So each of these would be 25. So ACG is 25 degrees. GCF is the other little piece that's also 25 degrees. JBK. JBK is the entire bottom right corner. In my opinion, this is the one that's the biggest step here, the least obvious to me. And the first time I looked at this, I was confused for a moment because they don't tell us anything about these numbers. But I want to redraw the picture for you a second. What if I took all the other stuff away and I just drew triangle ABC? We know that the top angle, 35 and 35, is 70 degrees. And we know angle C, the bottom left, is 50 degrees. Now back from a previous chapter, the triangle, the 3 angle measures have to add to 180 degrees. So 50 plus 70 is 120. Currently it adds up to 120. So 180 minus 120 is 60. Angle B, the bottom right corner, needs to be 60 degrees. So JBK is 60 degrees. GBK is just one of the 2 pieces. So if the whole thing is 60, to get just one of them, divide by 2, and they're both 30 degrees. You have to use the triangle sum, though, to find that third angle. The last one, DG and FG. These go from the end center to the side. End center to the side. The end center is equidistant to all 3 sides. So this one is 4, which means the other 2 are also 4. One last example, number 10. D, E, and F are midpoints. That means that the pieces FB and FC are congruent, EB and EA are congruent, DA and DC are congruent. AG is 12, CA is 18, DG is 3, CE is 24. Now I'm not going to put that one in the picture because CE is this whole length, and if I try to do one of these like squiggly things in the middle of the picture, it's just going to be messy. So I'm going to leave that one for now. And FB is 7. G is what is the name of this point? So let's see here. We have midpoints, and in the midpoint, there is a perpendicular symbol here on each of those midpoints, but look at where G comes from. G comes from this line, and the perpendicular symbol is on the other one. So we go from the midpoint up to corner A, to vertex A. These are medians. G is the centroid. So this one is the property where the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint. So let's try this. FG. Now remember what I just said. The distance from G to A is twice the distance from G to F. So you have to do 12 divided by 2, and you get 6. Now we want to know AF, which is the whole distance. So using segment addition, 12 plus 6 is 18. Now DA. DA is this piece right here, and we did something similar to this in number 8. The whole distance from C to A is 18, but we want to divide it into 2 pieces. 18 divided by 2 is 9. So both of those are 9. DA is 9, and DC is 9. The next one, GB, is right here. GD is 3, so GB will be twice that. 3 times 2 is 6. DB, the whole length from D to B, if one piece is 3 and the other piece is 6, 3 plus 6, segment addition, gives 9. The last one, GE and CG. This is the one where you don't know either of the numbers. So let's make the shorter piece X. The longer piece is twice that, so 2X. And together, the X plus the 2X needs to be the total length, which was 24. So X plus 2X equals 24, and solve. Combine like terms to get 3X equals 24. Divide both sides by 3. X equals 8. So GE equals 8. CG is 2 times 8, which is 16. And with that, you should have enough information to go ahead and complete your homework.